Have you ever wondered about the power of the sun, not just in shining bright in our sky, but in its ability to disrupt our technology and communications on Earth? This might sound like a page out of a science fiction novel, but it's very much a part of our reality. Our sun, the radiant ball of gas that keeps life on Earth sustainable, occasionally has these magnificent outbursts known as solar flares. These are sudden flashes of increased brightness, often near the sun's surface, releasing vast amounts of energy. Solar flares are categorized into three classes: C, M, and X, with X-class flares being the most powerful. Recently, we witnessed an X-class flare, the largest type of solar flare, which resulted in radio interference on Earth for a couple of hours. X-class flares can cause long-lasting radiation storms that disrupt communications, and in some instances, even cause blackouts. But why do these flares occur? Well, our sun follows an 11-year cycle known as the solar cycle. During this cycle, the sun goes through periods of high and low activity. We're currently nearing a peak in activity known as the solar maximum, expected around 2025, which means more sunspots, and subsequently, more solar flares. Now that we know what solar flares are, let's delve into how we detect them. Solar flares don't just sneak up on us. We have methods and instruments to detect them before they impact Earth. Now, you might be wondering, how do we actually spot these cosmic firecrackers before they affect us? The answer lies with the diligent work of NASA's Solar Dynamics Observatory, or SDO for short. The SDO is like our eye in the sky, keeping a constant watch on the sun's activities. It records solar flares in extreme ultraviolet light. To do this, it uses specialized instruments that capture high-resolution images of the sun every few seconds. These images allow scientists to study solar activities in extraordinary detail. It's like having a front-row seat to the most intense light show in our solar system. So, how does this detection process work? When a solar flare occurs, it releases a burst of radiation across the electromagnetic spectrum. The SDO's instruments detect this radiation, which appears in the images as a bright flash. From the moment of detection, we have anywhere from 8 to 20 minutes before the first particles, traveling at the speed of light, reach Earth. However, don't start panicking just yet. Not all solar flares have the same impact. The severity depends on the flare's class and the direction of the eruption. Scientists monitor these factors to predict the potential effects on Earth. With detection methods in place, the question then becomes, what happens when these solar flares reach our planet? When a solar flare hits Earth, it doesn't bring about a doomsday scenario. However, it does have significant impacts, particularly on our technology and communications. Let's delve into the actual repercussions of these flares. Earth's atmosphere does a fantastic job of protecting us from the harmful radiation of solar flares. But when these flares are particularly powerful, they can create disruptions in our ever-growing technological ecosystem. Take, for instance, the massive X-class solar flare that hit Earth back in December 2023. It was the biggest flare since 2017 and resulted in 2 hours of radio interference. This wasn't just a minor inconvenience. Pilots reported communication disruptions across the country. But it's not just terrestrial technology that's at risk. Space is teeming with satellites that guide our GPS systems, enable our communications, and monitor our weather. A powerful solar flare, like the back-to-back X-class flares in August 2023, can degrade these satellite signals and even cause potential harm to astronauts in space. The effects can also ripple out to our power infrastructure. Although not a common occurrence, there's the potential for a powerful solar flare to disrupt power grids globally. This could result in wide-scale power outages and have significant economic impacts. And then there's the sunspot connection. These are areas on the sun's surface that are cooler and less active than surrounding regions. But they can be the source of some serious solar activity. In May 2023, a large sunspot 3 times the size of Earth caused a powerful solar flare, leading to a radio blackout on Earth. So, while a solar flare might not spell the end of the world, it can certainly shake things up a bit, particularly for a society that's so heavily reliant on technology. These effects are indeed significant, but how do we deal with them? While we can't stop a solar flare from happening, we do have strategies to minimize the impact when they do occur. It's a bit like preparing for a storm on Earth, only this time, the storm is coming from the sun. One of the most immediate effects of solar flares is the interference with air traffic communication. Airplanes flying over the poles are particularly vulnerable to these solar outbursts. So, one strategy we have is rerouting air traffic. Yes, it's as simple as that. By avoiding the areas most affected by solar flares, we can ensure that pilots maintain communication with ground control, keeping our skies safe. But what about the satellites orbiting our planet? They are at the forefront of these solar storms and play a crucial role in our everyday lives, from GPS navigation to weather forecasting. Protecting them is a bit more complex. Engineers design satellites to withstand solar flares' intense radiation, often incorporating radiation-hardened components and shielding materials. However, protection isn't just about physical barriers. It also involves sophisticated software systems that can put satellites into a safe mode during a solar flare, reducing the risk of damage and prolonging their operational life. Power grids on Earth are another major concern. A powerful solar flare could induce currents in these systems, potentially leading to widespread power outages. To mitigate this, operators keep a close watch on space weather forecasts. When a solar flare is imminent, they can adjust the operation of the grid, for example, by reducing power loads or storing additional power to brace for the potential disruption. While these strategies are effective, it's important to remember that our understanding of solar flares is still evolving. As we learn more about these cosmic events, we can develop even better strategies to protect our technology and way of life. Solar flares are a reminder of our sun's immense power and the delicate balance that exists between it and our technology-dependent lives. So, while we can't prevent solar flares, we can certainly prepare for them, reducing their impact and ensuring that we can weather any solar storm that comes our way. With the sun nearing its peak activity in 2025, what can we expect in terms of solar flares? As we look to the future, the curtain of uncertainty begins to lift. As our sun marches towards the zenith of its 11-year solar cycle, the likelihood of witnessing more frequent and intense solar flares increases. The sun's tempestuous nature could result in phenomena akin to the recent X-class flares that disrupted radio communications across the globe. This is not mere speculation. The sun has a rhythm, a cycle, and we are approaching a crescendo, but this is not a cause for alarm. Rather, it's a testament to the dynamic nature of our universe. With the advancements in technology, we are more equipped than ever to monitor these solar outbursts. Observatories like NASA's Solar Dynamics Observatory are our vigilant sentinels, recording solar activity in extreme ultraviolet light and helping us understand these cosmic tantrums better. The possibility of more intense flares does mean a potential for increased disruption to our earthly technologies. Yet, it also means an opportunity for scientific discovery and understanding. Each flare, each sunspot, each coronal mass ejection adds a piece to the puzzle, helping us unravel the mysteries of our closest star. Remember, knowledge is power. With ongoing research and monitoring efforts, we are not just passive observers, we are active participants, ready to learn, adapt, and innovate. As we continue to explore the cosmos and deepen our understanding of solar activity, we'll be better equipped to navigate the challenges posed by these powerful cosmic events.